Alright, so today we're going to talk about question number 4 on the 2017 APBC free response question. This question in part A asks about to find the tangent line to the graph of h at t equals 0. The dh dt equation is given and an initial condition is given also, and so we're going to use those two to find the line tangent, the tangent line, and estimate the temperature of potato at t equal 3. So I've done everything out to construct a linear a line tangent to the graph. We need first the slope of the graph of the tangent line at t equals 0. We know that h of 0 equals 91, and we need to use h instead of t to calculate dh over dt. So we're going to plug in 91. We got negative 1/4 of 91 minus 27. Just like the equation, come out to equal negative 16, meaning temperature is decreasing. T equals 0. We have initial condition. At t equals 0, we have h equal 91. So we construct the tangent line y minus 91 equal to negative 16 of x, and so y equal to negative 16x plus 91, right? And we plug in 3 for x, which is x in here is t. We plug in 3. We got negative 48 plus 91 equal to 43 degrees Celsius. So to estimate heat at t equals 3, using the line tangent, the graph at t equals 0, cannot be 43 degrees Celsius, and we have to make sure to write the approximate symbol over here, the curvy symbol, because it's not the actual value, just so we can distinguish in part, and that's basically answer for part A, and that's the full points. Part B, the part B asks us to find this, or not technically not find, but use the second derivatives to determine whether the answer is part A is an underestimate or overestimate of the internal temperature. So we have to find whether basically the graph is concave up, concave down, whether or not the line tangent is below the graph or above the graph. So the second derivatives, which I wrote in terms of, which I wrote right here, negative. I put the negative outside because it's not gonna go anyway, and got dh dt off this whole thing of basically what is mean the of the derivatives of the first derivatives, and come out to be equal to negative 14 times dh over dt, because this is dh over dt, not, and we take in derivatives of h. So we got negative 1/4 times dh over dt. The first way you can do it is, is plug in dh over dt at time equals 0 and see whether the second derivatives at time equals 0 is positive or negative, and we couldn't and if it's positive, which I found over here, then the line tangent to the graph at t equals 0 is smaller. Is below the actual graph, and it's an underestimate. And second derivatives, the second way you could do it is plug back in dh over dt to the equation, to the second derivative formula. Dh over dt we plug back in here, negative 1/4 of h minus 27, and basically use 43, which is the estimated temperature, into the equation to find the second, approximate the second derivatives at t equals 3, which can kind of be also positive. And so I could say that since the second derivative is positive for h at t equals 0 and t equals 3, the graph is trunk above, and h of 3 estimate in part A is an underestimate of the actual value. Right. And we do all of this, you get 4 points for part B. And C, part C, this one you have to do, don't have involve a lot of steps of separating the variables and taking antiderivatives, and you have to be like careful plugging in your initial condition and doing antiderivatives, that kind of stuff. So you have to first separate the variables. You got dg over dt, and g on the other side. You have to separate, put g on one side, t on the other side. So you have dg over 2 g minus 27 of 2 over 3 equal to negative dt. The antiderivatives is because you have g minus 27 in the denominator, you can write this power in terms of negative power. So you got g minus 27 to negative 2/3. Antiderivative is 3 times g minus 27 to the 1/3 equal to negative t plus c. Alright. So all we have to do now is we got the antiderivatives. We have initial condition also of g of when t equals 0, g equal to 91. So we plug in initial condition to find the constant value of 91 minus 27 to the 1/3 equal to 0 plus c. So c equal to, let's see, 91 minus 27 equal to 64. 1/3 equal to 3 times 16 equal to 48. Alright. And so you put c back in. That's access to find, it asks to find time variance t equals 3 for this model. So you got so we have to separate. So 3 of g minus 27 of 1 over 3 equal to negative t plus 48. So we got g minus 27 to 1 over 3 equal to negative t over 3 plus 3, 16. And so you got g minus 27. You cube the right side, so negative t over 3 plus 16 cubed. G equal to t over 3 plus 16 cubed plus 27, and we estimate g at find g at time equal 3. Alright, so got t equal 3, you got negative 1 plus 16 to 3 plus 27 equal to 15 cube plus 27. Actually, okay, I see. So actually 64 to the power 1/3 is equal to 4. Sorry about that. And come out to be 12. And so we have to replace everything with 12. So you got 48 plus 12. 16, 12 divided by 3 is 4. 4 and 4. And so everything out to be right. 3 to 39 plus 27 equal to 36. Yep. 27. Oh, it messed up again. So 3 to the third power is 27. Not 9. I just woke up today, but equal to 54. So that's number 4. Answer for g of t. G of 3 equal to 54 degrees Celsius. Ask us anything else? Nope. So this is basically it. So firstly, make sure separate variables carefully. And do algebra 1 math carefully. Don't be like me. All right. So thank you for watching.